students? I hope all of you remember the formula for this. If you don't remember, you have got to derive it.
Yes.
You have got to derive it. If you don't remember, you should be able to derive it. Okay? Presuming that you don't know the formula and you have to derive. So what will you do here? So you will quickly derive this formula. Right? See, this is what you have to practice in these sessions. Okay, this is the original rubber. Okay, now if you don't know how to, I mean the formula for this, because it might happen, it so happens in the examination. Okay, so from here you should take the length x and take this element as dx. Okay, this total mass is m and the total length it has will be l. This is the data that they have given. Okay, so what happens here? Just apply the signs. Just apply the signs. So here, if you see here, this portion is causing the force on this element. That is all you have to see. So you just write the equation for this element. What is that you are going to write? Y is equal to the force. What will be the force? M by L into X into G. I suppose you understood. This is the force due to this element. Hello? That is the force due to that element divided by the cross-sectional area. Okay, that gives you the stress. And what is the strain? Strain is, see, because of this, the original length of this small element, okay, the original length of this small element was dx. Now this dx elongates. See, this dx now elongates, okay, by dy. This elongates by dy. Okay, so therefore the strain will be dy by dx. Okay, so this is how you have to formulate the equation, and then rest of the things you have to integrate it. So y into dy. Okay, so this integration is y means the amount of elongation. Okay, so assuming that it will elongate finally by delta L. Okay, and here right side you will get m by L by A and G as constants, and this dx can go up. Of course, you have to follow proper calculus, because you have to write dy by dx as delta y by delta x limit and all the things. Well, I have just skipped those steps. So right here x dx. Okay, so here the x will go from 0 to L. Okay, integrated. So you will get here y into delta L is equal to m g, here x square, okay, x square by 2, and of course LA will be there, and this will be 0 to L. So this becomes m g L square, 1 L will go, right? So I will keep that L there, right? And then I will be having here only A, 2A coming up. And what I want is the elongation due to this whole weight, that will be equal to half m g L by y. I suppose this is the formula you have used. Hello?
Yes.
So if in examination, if you don't remember, it's okay. You should not be tensed. So if you are able to derive it quickly and then use it, well, you have learned physics. That's what I want. That is how I conclude, that students have learned physics. Of course, if you write the values, because all these values they have given here, what is the answer that you have got? If you plug in the values, hello?
Sir, I got your
A, B, C, B. Which one?
B.
Everybody got B? Hello?
Yes, sir. Yes.
Okay, done. So I will go with right. B is the option. Right? Shall we go to the next one, students?
Yes. Yes.
Okay. Yeah, please solve this problem. Well, if you don't know the theory, I will explain the theory here. You be free and frank. See, in the case of this, the force by area, you will have to consider it as pressure. Correct? Hello?
Yes.
See, if you remember, bulk modulus B will be equal to what? See, here F by A becomes delta P. Right? Divided by delta V by B. And this will be with the minus sign. Because the volume is decreasing.
Yes.
Right. Okay, so this is it. So in this case, what all they have given? They have given this quantity. Okay, and an increase in the pressure to liquid by this, and they have given you this value. So you have to find out this value. That's it. Hello?
Yes, sir.
Correct? You have to find out this value. See, this minus sign signifies that the volume is decreasing. That's it. That's all. So here, simply it becomes delta P will be equal to bulk modulus. What is the bulk modulus here? 2100 megapascal. 2100 megapascal converted into pascals, and 1 pascal is what? 1 Newton per meter square. Hello? You have to tell me, huh?
Yes.
Right? Because you have to take it in SI units. Right? So B value and into delta V by B. That is, there is an increase of 4, right, for every 1000. Correct? No, I am just writing it. You have got to put your use your head and tell me whether what I have written is right or wrong.
No, sir.
Good. So you write like this: 0.04. Write it as 0.004 by 100. Okay, that will be fine. So you have to solve with me. It is not that I will solve, you take down. I want you to be involved. Sometimes I deliberately do some mistake. Okay, you just have to calculate this. Right? So here it goes. There's this, and then again here. So 21 4 the 96. So there will be 96 and 0.004. Right? So 0.004. So it will be 4 into 96. And so 3 zeros eclipse. So then you have to add 3 zeros to this. Remaining 3 zeros to this. So 96. Sorry, 21 for the 84. 84 followed by 3 zeros. Right? So it is now, what are the answers? 8.4 kilopascals or 84 kilopascal. Which one is right? Pardon? D is the option. Correct? All of you got this D option? Hello?
Yes, sir. Yes, sir.
Right. Simple. A ball falling into the lake of depth 200 meters show 1% increase in its volume at the bottom. What is the bulk modulus of the material? So the same formula, but here is again 1% decrease in its volume. So here the change in the pressure at the top and the pressure at the bottom. It is rho GH. That's all. So in this case, what is the bulk modulus? So the change in the pressure. See, the ball is at the top, only atmospheric pressure. At the bottom, it is atmospheric pressure plus rho GH. So rho GH. Water is, they have told, falling in a lake. Lake means it will be water. Rho is 1. G is 10. Okay. And H is 200. So it will be rho GH. Rho GH. Okay. That is, what is rho GH? Rho GH is nothing but delta pressure. Right? Hello? Divided by change in the volume. What will be the change in the volume here? That is 0.1%. So you write 0.1 by 100. Okay. So rho for water is 1, G is 10, and H is 200. Okay. Into 100 divided by 0.1. So again here 1, 2, 3, 4, 5, 6 zeros. Right?
No is work one side, we should take in kg per meter square.
Huh?
Density we should take in kg per meter square.
And G value is 9.
Yes, yes. And look at the option, G value is 9.8. Correct. So row value you will take it as what? So G, see, look at the options. You will not get it in 2s and all. So therefore you should take it as 9.8. Okay. So in this case, SI system, what will be rho? How much will be rho? 1000 kg per meter.
1000 kg per meter square.
Correct, no? 1000 kg per meter cube. Take it as 1000 kg per meter cube into G is 9.8. Okay. And H is 200 meters. Right? Divided by 0.1 into 100. I will pull the 100 up. Okay. Now you will get it as 19.6. Just multiply the two things. And now adjust for the zeros. So here I just multiply this 3 plus 2, 5, 5 plus 2, 7, 7 plus 1, 8. 10 to the power of 8. Okay.
Yes.
So here you got 19.6 into 10 to the power of 8. A should be the option. Did you all get that?
Yes.
A is the option. Right. A is the option. Right. Shall I proceed, students?
Yes, sir.
Yes, sir.
2 wires, same diameter of same material having length L to width, the force applied on each, the ratio of the work done into. See, the force applied is same, continuous, and they are asking you the ratio of the work done. So that means F into delta L. In which case delta L will be more, because F is same. More the length, more will be delta L. Conceptual problem, no calculation is necessary for this. See, this can be done by visual inspection also. So here you see the lengths are different. They are asking you the ratio of the work done. Work done is F into delta L. Okay, whichever delta L is. Okay, that is F into delta is the work. Right, and in this case you see F is same, material is same, okay, the area is same, everything else is same. Okay, so therefore directly you can say here delta L, you can write it as FL by AY basically. So here F is same for both the materials, only this L will be different. This is same, this is same, isn't it? So therefore here delta L is proportional to L. Okay, and F is same. So here length is twice, means delta L will be that twice. Okay, so in the first case the delta L will be having say 1 unit. So if L is 2L, then the delta L will be 2 units, but the force is same. So the work done in the second case will be twice. So therefore you should go with this.
Yes. Yes.
Okay? So you see concepts, how many multi-concepts are used. You have to be strong in the concepts. You can do it, right?